Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test. This is going to be a thinking question. So we're told if y is equal to f of x squared minus 4x plus 11 and f prime 8 is equal to 2, we have to determine dy dx at an x value of 3. So this is one of those chain rule questions, and we've gone through these kinds of thinking questions in the lecture videos. I actually have a bunch of them because they're very popular kinds of questions that can come up where they set up these composite functions in different formats. They give you a bunch of information and you have to find the value of a derivative at that specific x value that they give you. So notice here we have y is equal to f of a function. Notice we have a quadratic within the function f. Now we don't know what that function f is, but we are given some information about it. So for now, what I'm going to do, let's keep this general. This quadratic within the f, I'm going to write that quadratic as g of x, like that, right? So it's f of g of x. It's basically a composite function. And if you remember from the lecture videos, right, the chain rule, the last section in this unit, we know that the derivative, what would we do? We would take the derivative of the outside function, keeping the inner function the same, times the derivative of the inner function, like that. So if they are asking for dy dx here, which we have an expression for now, at an x value of 3, right? So dy dx, basically at an x value of 3, let's plug in 3 for all the x values. So it would be f prime of g of 3, right here, times g prime of 3, like that. And so notice that in this expression now, we're dealing a lot with the function g of x. And what did we let g of x be? It was the quadratic. So let's actually write that on this side. I should have maybe did that at the beginning, right? We let g of x be that quadratic. So notice we could find g of 3. Now what about this g prime of 3? Well, we would have to take the derivative of g of x, which would be 2x minus 4, like that. Now, if you didn't want to bring in this, this function g of x and let it be the quadratic, you can also write this derivative. You could have also wrote this derivative by keeping the quadratic. So the derivative would be the derivative of the outside function, keeping the inner function the same, times the derivative of the inner function, which would be 2x minus 4. Like that, right? This and this, they're basically the same thing, right? But I brought that g of x to represent the quadratic just so we can, just because I've gone through that format in the lecture videos, right? Where just the general format, where if we have f of g of x, the derivative is f prime g of x times g prime of x, right? So I wanted to bring that format back in that we use in the lecture videos. But you could have also kept the quadratic left as is and then plugged in that x value of 3 over here. So whichever way works. Now, if we do that, so plugging in that x value of 3 into the function, right, into this x squared minus 4x plus 11, so what would g of 3 be? That's going to be 9 minus 12, which is negative 3, plus 11, which gives us 8. So we know g of 3, or plugging in this x value in the quadratic, that's going to give us 8, like that. And then what's the value of the derivative? What's g prime of 3 at that x value of 3? Plugging in 3 into the derivative, 2 times 3 is 6, minus 4 is 2. So that's going to be 2, like that, right? G prime of 3. Or at an x value of 3, 2x minus 4 takes a value of 2. And notice, maybe you were wondering, what are we going to do with this f prime of 8, right? There's no 8 floating around here given. Well, notice it comes up here. A lot of times, the values that they give you, you may not see it right away, but after you do algebra, you'll see where you have to plug in the parameters that are given. So we know that f prime of 8 is equal to 2, so we'll have 2 times 2, which is basically 4. And that ends up being the final answer to this question. Sorry, I kind of went all over the place here. Hopefully you followed everything that happened. Again, I have lots of examples like this, these chain rule thinking kind of questions. in the lecture videos. Make sure you go through all of them. There's like a big list there because there's a bunch of different scenarios that can come up, and you have to be able to adapt, know the chain rule well, and then be able to adapt with the parameters that they give you. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.